Hello friends. Today in lecture number 5 of the subject RCC, we will study the A2 type problem, that is finding actual stresses, strains and miscellaneous problems. In the first problem, a singly reinforced beam 230 mm by 400 mm deep effective is reinforced with 4 bars of 16 mm diameter. Find maximum stresses and strains in steel and concrete if the beam is subjected to a factored moment of 60 kN meter, M20 and Fe 415 used. Now, to start with, we will note down the given data. So, solution. Data given. B 230 mm. Small d effective depth is given as 400 mm. Is reinforced with AST 4 bars of 16 mm diameter. So let us calculate area. 4 into pi by 4 into 16 square. So this is 804 mm square. Okay. Then the grade of steel and concrete is given. So maximum stresses allowed, maximum stresses in steel is 415 Newton per mm square, and in concrete 20 Newton per mm square. And further it is mentioned that the beam is subjected to a factored moment 60 kilonewton. What is required? The required is actual stresses in steel and concrete. Stresses and strains. Actual stresses and strains in steel and concrete. Now to start with, as area of steel and size of beam is given, let us calculate XU actual by the formula CU is equal to TU. That formula is 0.87 FY that is, this is TU, divided by 0.36 FCK into B. XU I am taking on left side. So this is equal to 0.87. Fy is 415. AST 804 divided by 0.36. FCK is 20. B is 230. So after calculation, XU actual is 175.35 mm. Then let us find XU max or XU limit. Now for the grade of steel Fe415, XU max is 0.48D. This is for Fe415 grade steel. So 0.48 into D, D is 400. So this is equal to 191.4 mm. Now let us compare this XU actual and XU max. XU actual in this case is less than XU max. That means 175.35 is less than 191.4. So this is under reinforced section, which is allowed. Remember, over reinforced section is not allowed. So we confirmed that it is under reinforced section. Now to calculate actual stresses in steel and concrete, what I will do, I will equate mu is equal to Tu into Z. Mu is given as 60 into 10 raised to 6. It is in now Newton mm. The given mu is in kilonewton meter. So I have converted it to Newton mm is equal to 0.87. Stress in steel actual, I will write Fy actual. 0.87 Fy AST into bracket D minus 0.42 XU actual. Because here we will consider the actual depth of neutral axis. So 60 into 10 raised to 6 is equal to 0.87 Fy actual, stress in steel actual, AST is 804, D is 400 minus 0.42 into 175.35. So simplify this, you will get stress in steel actual as 262.76 Newton per mm square. Now the actual stress in concrete. For that, what I will do, mu is equal to Cu into Z. Mu 60 into 10 raised to 6. Cu 0.36 FCK XU actual B into lever arm D minus 0.42 XU actual. So 0.36 FCK actual, FCK actual, or you can say stress in concrete actual. XU actual is 175.35. B, the width of the section is given as 230. D 400 minus 0.42 into 175.35. So simplify this. You will get stress in concrete actual is equal to 12.66 Newton per mm square. But the actual stress in concrete is at the outermost fiber is 0.45 FCK actual, that is 0.45 into 12.66, that is equal to 5.65 Newton per mm square. So we got actual stress in steel 262.76 Newton per mm square and actual stress in concrete 5.65 Newton per mm square. Now about the strain in concrete and steel. The actual strain in steel epsilon SU actual is equal to Fy actual upon 1.15 ES plus 0.002. So this is the strain formula. So strain 262.76 is the actual stress Fy actual divided by 1.15 into ES 2 into 10 raised to 5 plus 0.002. So this is equal to, after calculation, you will get 0.00314. No unit for that. This because this is the strain. So actual strain in steel is 0.00314. Now, actual strain in concrete you can find by similar triangle. See, by similar triangle we can find here actual strain in steel 0.00314. This is XU actual. This total is effective depth, small d. So this is D minus XU actual. Here strain in concrete actual. So strain in concrete actual divided by XU actual using similar triangle rule. This is equal to 0.00314 divided by D minus XU actual. Now strain in concrete actual, XU actual we know. XU actual is how much? XU actual we got it as 175.35 175.35 is equal to 0.00314. D is 400 minus 175.35. So simplifying this, what we will get, strain in concrete actual is equal to 0.00245. So this is the strain in concrete actual. This is the strain in steel actual. So final answer I can write actual strain in steel 0.00314 and in concrete 0.00245. This is the final answer that we got. Very simple. What we did, we first checked whether the beam is under reinforced or not. Then we equated the actual mu to Tu into Z and then found the stress in steel. Then we equated mu to Cu into Z. Then we found the stress in concrete. Then using actual stress in steel, we found actual strain in steel. And using the similar triangle principle, we found the actual strain in concrete. So this is another type, analysis type. Now Another problem, which is very simple problem, calculate the values of critical neutral axis and maximum moment of resistance for M15 and Fe415. Okay. Now for that, let us note down data. Calculate the values of critical neutral axis and maximum moment of resistance for M15 and Fe415. Only data given is M15, that is the grade of concrete, and Fe415. Now, here I will consider the strain diagram as usual. The It is asked critical neutral axis, so it must be a critical section or a balanced section. Critical section is also known as balanced section. It is also known as economical section, and for this is XU max. And in this section, both the strain, that is strain in concrete, reaches its maximum permissible value, and strain in steel reaches its maximum permissible value Fy upon 1.15 ES plus 0.002 at the same time. Simultaneously, the values of strain reaches their maximum. So this is D minus XU max. Now I will substitute the values of Fy and ES here, as it is given Fe415. So this is 415, Fy is 415 divided by 1.15 ES, always 2 into 10 raised to 5 plus 0.00. So if you simplify this, what you will get, strain in steel ultimate is equal to 0.0038. Now using similar triangle XU max upon 0.0035. This is given in IS code. Both these values are given in IS code. That is maximum strain in steel and maximum strain in concrete. This must be equal to D minus XU max upon 0.0038. So simplify this. What you will get? Take this 0.0038 divided by 0.0035. XU max is equal to D minus XU max. So you can simplify this. You will get, after simplifying this, you will get XU max 0.48 D. Once you get XU max, using the equation mu max is equal to Cu into Z. Cu is 0.36 FCK XU max B into bracket D minus 0.42 XU max. So 0.36 FCK as the grade of concrete is given as 15. XU max is 0.48 D into B into bracket D minus 0.42 into 0.48 D. So simplify this, what you will get 2.066 B D square Newton mm. This is mu max. Mu max for what? Mu max for M15 and Fe415. So I will repeat the steps. Only grade of steel and concrete given, and it is asked to find the depth of critical neutral axis, that is for balance section, and maximum moment of resistance, that is mu max. Now consider this strain diagram. This is strain diagram. The maximum strain in steel is given as Fy upon 1.15 ES plus 0.002. This is given in IS code. Maximum strain in concrete at the outermost fiber is 0.0035. The depth of neutral axis is XU. Total depth is from this to center of the steel is small d. So this is small d, effective depth. So from neutral axis to the center of steel is d minus XU max. Substitute the value of Fy as 415, ES 2 into 10 raised to 5. Calculate the strain in steel, that is 0.0038. Then using similar triangle rule, find the value of XU max in terms of D. Then equate mu max to Cu into Z. Cu is 0.36 FCK XU max B and Z is D minus 0.42 XU max. Substitute the value of FCK as 15. XU max is 0.48 D. Small d is 400. Sorry, it is not given. We are finding in terms of B and D. So keep D as it is. Then again XU max is 0.48 D. So simplify this. You will get mu max in terms of BD square, that is 2.066 BD square. Now this is constant for M15 and Fe415. If you know the values of B, suppose B is 300 mm and effective depth is say 500 mm, then after substituting these values in this equation, you will directly get the value of mu max. Now let us consider the third problem. Third problem. Find the limiting moment of resistance and area of steel for a beam 280 by 560 mm effective. Okay. Now data B 280 mm, effective depth small d 560 mm, M20 means FCK is 20 Newton per mm square, Fe415 means Fy is 415 Newton per mm square, Okay, Newton per mm square. And what is asked? Mu max and AST. These are the required parameters. Now, as the grade of steel is given for Fy equal to 415, that is Fe 415, Mu max or Mu limit is 0.138 FCK BD square, that is equal to 0.138 FCK 20, B is 280 and D is 560 square. So simplify this, you will get the value of Mu max 242.35 into 10 raised to 6 Newton mm. This equation we derived in the second lecture, that is for Fe 415. Mu max is 0.138 FCK BD square. Now to find area of steel, what we do? We will equate to find area of steel. We will use equation Tu is equal to Cu. Tu is total tensile force given by steel 0.87 Fy AST is equal to 0.36 FCK XU B. Here, as this is balanced section, we will substitute the value of XU as XU max, which is 0.48 D. So, AST, we require AST is equal to 0.36 FCK. What is the grade of concrete given as 20? So 20 into XU max, that is 0.48 D, 0.48 D into B divided by 0.87 Fy. So AST is equal to 0.36 into 20 into 0.48. The value of D is 560 and 280. B is 560 and 280. 560 and 280 divided by 0.87415. So after calculation, we get AC as 1497.7 mm square. So this is the required answer. Area of steel is equal to 1497.7 mm square, and required Mu max is 242.35 into 10 raised to 6 Newton mm. So this type of problem can be asked for 4 marks in examination. So just I will summarize in the first problem what we studied: how to find the actual stresses and strains in the beam with given Mu and the size of the beam area of steel and grade of steel and concrete. In second problem, we derived the equation for XU max and Mu max for a particular combination of grade of steel and concrete. And in the third case, we found the value of Mu max with given grade of steel and concrete and size of the beam. We also found the area of steel required for balanced section. Thank you.